Today, we're diving deep into the tokenomics of Datagram. Now, they're making a pretty bold claim that they've engineered a truly sustainable crypto economy right from scratch. So let's take a look under the hood and see if the mechanics really live up to that vision.
Look, it's a totally fair question, right? We've all seen this story play out before. A project launches with a ton of hype, the price moons, and then it all comes crashing down. Usually because of crazy inflation, speculative dumping, or just a total lack of any real-world use. So is Datagram just more of the same? Well, they're arguing that what they've built is fundamentally different.
And that difference, well, it really starts at the very top. This quote from the CEO, Jason Brink, it sets the tone for everything. The entire economic model that we're about to break down is designed to support a network that actually does something useful. Providing real services like AI and real-time communication instead of just being a vehicle for speculation. So, what's the big puzzle? How do you reward all the people participating in your network without just printing money into oblivion and causing hyperinflation? For Datagram, it all begins with their rewards engine. This is really the heart of the system, the mechanism that compensates node operators for powering the whole thing.
First things first, there is a hard cap. A finite supply, only 10 billion Dgram tokens will ever exist. Period. This isn't one of those projects that can just print more tokens whenever they want. Right away, that creates a fundamental level of scarcity, which is absolutely crucial. Okay, now this next part is maybe the most important concept to get your head around. Latent supply. See, instead of just dumping a fixed number of reward tokens into the market every single day, the Datagram protocol does something smarter. It looks at the total pool of tokens that have not yet been released. And that pool of uncirculated tokens, that's what they call the latent supply. And here is how they use it to control inflation. Every day, the protocol takes a tiny fixed percentage, just 0.125%, of whatever is left in that latent supply pool. That number becomes the total rewards for the day. Now here's the beautiful part. As more tokens get rewarded and enter circulation, that latent supply pool gets smaller. And as the pool shrinks, the daily rewards shrink too. It creates this natural, elegant decay curve for emissions. So where do these daily rewards actually go? It's a pretty simple split. Half of all the new tokens minted each day go directly to the people running the full core nodes. These are the real backbone of the entire network. The other 50% is set aside for things like ecosystem growth and rewarding other network participants. All right, having a smart rewards model is great, but honestly, that's only half the battle. How do you get regular people and businesses to actually use the network for its intended purpose? Datagram's answer is what they call a tri-token utility loop, and it's specifically designed to solve one of the biggest headaches in crypto, price volatility. Just think about it for a second. Imagine you're a business and you need to pay for, say, a month of data processing on the network. You can't have your bills suddenly jump by 50% overnight just because the token's price went on a wild ride. It's an accounting nightmare. It makes planning impossible, and it's a huge reason why real businesses stay away from using crypto for services. You need predictable costs. So here's their solution. It's this really clever, self-contained loop. First, a user who wants to use the network takes their Dgram tokens and burns them. In exchange, they get these things called data credits, which are pegged to the US dollar, nice and stable. Then they spend those credits to pay for services. The node operator, on the other side, the one who actually provided the service, earns service points. And then, this is the magic, those points automatically get converted right back into Dgram tokens for the operator. And what you end up with is this beautiful economic flywheel. Users get the stable, predictable pricing they need, which makes it possible to build real businesses on the platform. Node operators get rewarded in Dgram, the network's core asset. And the whole system is driven by actual usage, which puts constant buy and burn pressure on the Dgram token itself. It's value driven by utility. Okay, so we've got sustainable emissions and a real utility loop. Fantastic. But what about that other great destroyer of token economies? You know what I'm talking about, the massive token dumps from early investors and team members as soon as their tokens unlock. Datagram's answer to this problem is something really innovative called NFT capsules. We've all seen this with traditional vesting. There's this unlock cliff on the calendar, everybody knows it's coming, and when that day hits, a huge wave of tokens floods the market and the price just tanks. It creates these massive, predictable sell-offs. The Datagram model with these NFT capsules is designed to give early holders the liquidity they might need, but without wrecking the market for everyone else. How? By turning the vesting contract itself into a tradable asset. So the schedule itself is pretty standard. At the token generation event, or TGE, you get 10% of your tokens right away. The other 90% then unlocks gradually, day by day, over the next 12 months. But here's the catch. The capsule itself has an 18-month expiration date. If you don't claim your tokens by then, they're gone. And the way you actually claim them, well, that's where this gets really clever.
So the key here is that your entire allocation of locked tokens is represented by an NFT. To even start claiming the tokens that have vested, you have to prove you're contributing to the network by running a node for 100 hours. Now, if you need cash, you don't dump your tokens on the market. You sell the entire NFT capsule to someone else who wants to be a long-term participant. And there's a huge incentive to hold on. If you try to cash out early, half of your unvested tokens get burnt, and the other half get redistributed to all the other capsule holders who stuck around. It's a system that rewards conviction.
Okay, so let's pull back and put all these different pieces together on the board. We've got declining emissions from the latent supply model, we've got a utility-driven demand loop, and we have this really novel NFT vesting model. What does this all add up to when you look at the big picture?
You can really see the core philosophy here, can't you? Every single feature we've talked about was engineered to solve a very specific, very common problem that has plagued crypto economies for years. Latent supply tackles inflation. The utility loop solves volatility for users. NFT capsules prevent investor dumps. It's this whole system of checks and balances, and it's all designed for long-term health, not for a short-term hype cycle.
And what's really interesting is that the system is designed to evolve over time. At the very beginning, when the network is new, the rewards will heavily favor just simple uptime, basically rewarding node operators for just being online and keeping the network stable. But as the network grows and matures, the rewards are planned to shift to start prioritizing the nodes that are actually doing the most work, the ones handling the most AI jobs or communication traffic. The focus moves from just stability to real utility.
And this really brings us full circle, back to that core idea from the very beginning. Every one of these intricate mechanics, the latent supply, the tri-token loop, the NFT capsules, they are all in service of a single overarching goal: to create an ecosystem where the value of the network and its token is directly tied to how much it's actually being used to deliver real-world services.
You know, Datagram has clearly put a massive amount of thought into engineering an economy that's built to last. By methodically addressing the classic failure points of tokenomics, they've designed a model that champions utility, stability, and long-term alignment over short-term gains. The big question, of course, is, will it work out in the real world? And could this complex interlocking system actually become the blueprint for future decentralized physical infrastructure projects? Well, only time will tell.